First of all, very briefly, just to summarize, I mean, Cepi's mission is about funding and coordinating efforts for finding a vaccine. Is that correct? And also, how do we do that?
No, that's correct. I mean, Cepi was set up and launched, a bit more than 3 years ago.
Yeah.
Exactly because the world kind of realized that being better prepared for these kinds of what we call emerging infectious diseases is an area where the normal commercial system doesn't help the world to be prepared. Because, of course, if you're a company, you don't know when this will become big or whether your investments will be worthwhile. So basically, and that was the lesson the world learned from Ebola in West Africa. And so, therefore, a number of countries and some philanthropic groups like the Bill and Melinda Gates Foundation and Wellcome agreed to set this international organization up so that the mandate is to drive vaccines as far as possible so that they can be at least closer to being ready when they are needed.
Yeah. And
I think,
sorry, but close to being ready. And how do you do that? I mean, you choose, you map all the world, all the labs in the world, and then you choose where to put your money in?
Yes, it's the first step has been to work with the World Health Organization.
Yeah.
And they have a list of diseases that they see as potential threats, but where there's not sufficient research.
Yeah.
And then we have a scientific advisory committee that, based on that list, says which of these would a vaccine make sense and would be possible. And once they've made that decision, then we turn around and we say to the world, listen, we have some money, and do you have a good project? So we have calls for proposals, and then again it goes back to the scientific advisory committee that sort of goes through all of this together with other experts and says we believe that these projects are the ones that have the biggest potential for success.
If I'm not mistaken, you have done so far 5 calls for proposal, right?
Yeah.
And the fourth one that was October 2019 was about disease X, so to speak. In which way all of these calls helped you in advancing a possible vaccine for COVID-19 now?
Absolutely. So particularly 2 of them. I mean, one was for another coronavirus, which is the MERS, Middle Eastern Respiratory Syndrome, which has a very high mortality rate. And so we were already engaged on vaccine development for MERS. And it's kind of a distant relative to the novel SARS coronavirus. And secondly, we had, as you say, this call for, I guess, disease X, which then was looking for good, what we call platform technologies. So these are, Bill Gates likes to call them plug and play. So you have a sort of component which is well researched and it's safe and it's and you can then just plug the new antigen, as it's called, on that, so that you have a vaccine much more quickly. So when COVID-19 came along, we were able to turn around and say, could you change your focus? And these were being tested on different pathogens, and then and of course, a number of them said yes, of course, and they threw themselves onto this new coronavirus.
All of this, in a way, bring us to another question, which is, this time there was a quick response compared with other vaccines, and most of it was thanks to you in a way. How was it possible? I've read somewhere that you guarantee a 16 weeks period from starting to work from clinical trials, something like that.
Yeah,
You have already partially replied to that, but please elaborate a little more about this.
Well, I wouldn't say we guaranteed. We kind of challenged the developers to say that's what we're looking for. You know, we need to dramatically improve development times if we are going to be able to react to a new disease. So that was the whole one of the purposes with this call. You know, the call last fall.
Yeah.
So the reason it's been able to go so quickly is as I talked about, we already had some projects that could be repurposed.
Yeah.
Secondly, I mean, you have to give the Chinese credit for having released the genetic sequence relatively early and very publicly, so that everybody could start working on it. And thirdly,
yeah,
I would say, humbly, that it was lucky that Cepi was at least 3 years old and was able to. We already had some funds that we could pull from, and so basically we sort of took $100 million, which were planned for future other uses, but said we now need to prioritize this.
How much money did you say?
100 million US dollars.
Yeah. Yeah, which is a good start, of course.
Yeah.
If I understand correctly, the traditional way to go to vaccines is either inoculate live virus, a weakened virus in a way, or inactivated virus. What's wrong with these two traditional approaches?
Nothing is directly wrong. I think it's just that there's a benefit from having also more approaches.
Yeah.
And because in a situation like the one the world has now, there are three things that are important, I think. It's speed.
Yeah.
We get a vaccine as quickly as possible. It's scale.
Yes.
And it's access, and we'll talk more about that.
Yes.
And so, but to be able to have speed and scale, it's a little bit of a trade-off sometimes. So, because some of these newer technologies are probably quicker.
Yeah.
Maybe quicker. I don't know yet, but they might be quicker. But then, as you say, that these old, true and tested, we know that can be produced in big quantities at least. So that's why we want to have the whole breadth in our portfolio, so that we can basically see which ones succeed at the end of the road.
So to sum it up, the old methods can do more scale, and probably the new methods can do more speed. We hope so, at least.
Yeah. Hypothetically,
yeah. And among the new methods, to simplify a little bit, if I'm not wrong, one is focused on attacking the protein structure of the virus, and like Novavax is doing. The other one is starting from RNA. I mean, it's working more directly on RNA, like Moderna and CureVac are doing. Is this correct? And which one do you find more promising, and why?
It's almost correct, because I think, and I'm not 100% sure about the Novavax sample, but I think it's actually not attacking the protein structure. It's actually presenting the body with a protein from the virus.
Yeah.
And so it triggers the antibody response. Whereas, as you say, the RNA ones are providing, the genetic codes to the body to produce those same proteins.
Yeah.
So it's a different mechanism, which, depending on biology and many things, we'll just have to see which one is most effective. And at this stage, we can detect which one is most promising.
Yeah, but if I may say, judging from the amount of money that you gave to, I think, CureVac, that I would imply that you think that CureVac is more promising because that you gave them, if I'm not mistaken, much more money than to Moderna and Novavax.
Well, you have to look at total budgets, and the fact is that Moderna was already quite well financed through the National Institute of Health in the US.
Okay.
So we just gave a small contribution to kind of help it. And CureVac, we had to sort of start more from scratch. Now later on, they've been supported by the European Commission. So I think this is all a big global puzzle. To promote these vaccines.
So what you're saying is that we cannot judge, we cannot imply from the amount of money that you give it to someone or to someone else the fact that you believe more in one way or in the other.
No, that's correct. We are really just hedging the world's bets. If you understand what I mean, we're putting some money here, some money there, some money here. We try to have a broader array of possibilities. And again, it depends a little bit on who else is co-funding these projects.
I see. By and large, on how many different kind of vaccine do you work right now, or do you put your money? Because is that possible you work on 4 different strands of vaccines, so to speak?
So we have 8 projects that we are funding right now. We are looking at 1 or 2 more. So I think we'll end up, with probably 9, let's say 9 projects.
Yeah.
As I say, we took some monies to sort of get these projects going. And then we've done a calculation. We think that with this portfolio of projects, there's a reasonable chance that we end up with 2 or 3 vaccines that can be scaled at the end of the development process.
When? At the end? Yeah.
At the end of the development process.
Okay.
So in 12 to 18 months.
Okay. So in a way, you have already replied to another question, which was I was trying to have some estimate, time estimate from you, because we all know and we keep hearing from every source, that the traditional wisdom about vaccines time frame is 12-18 months. What are your expectations, and how do you hope to accelerate, to expedite the process, so to speak?
So, I would say that the traditional process is actually 6 to 7 years.
Yeah.
And it's almost scary because we've been saying 12 to 18 months for a couple of months now, and it has become the new global expectation. And that is very ambitious.
Yeah.
And the way we are trying to achieve that is through doing some things in parallel rather than traditionally you do it very quickly. So the World Health Organization is looking at ways to do clinical trials that would speed up the process, but without taking away the safety aspect. And the most important piece is actually that one can start developing the manufacturing processes in parallel. So usually what you do is, you take a vaccine through, it's called phase 1, so you test it on humans. Then you take, you take a month or two to analyze results. Then you see, yes, this is worthwhile going on with, and then but maybe we should change it a little bit here or there, and then you have to build a factory almost, and that takes a number of months. And what we're doing now is we're actually starting to invest in those factories already now. And it's what we call investments at risk. So if it turns out it's worthwhile to continue, then we're ready to go. But there's also then the risk that, no, the results were too bad, we don't need that manufacturing. But this is the only way to get to that kind of speed that we're talking about. It makes it a bit more risky, but compared to the world's enormous needs, it's definitely worth.
Yes. Please let me understand better this passage. What you're saying with this investment at risk is that even you don't know yet which vaccine will prevail, so to speak. You are already contacting manufacturing plants to say, in a way, we book you. I mean, we want you to be prepared. Once we are ready, you have to be ready.
Exactly.
And in order to do that, you have to pay these guys, these manufacturers, in order to get ready. Okay, that's the economic risk you were talking about. I see. And these manufacturing plants are all over the world. I mean, China, US, Europe, all over the world.
That's great. Yes, and it's an important point actually for us that they should be all over the world, so that both to make it logistically easier to supply different regions, and also to ensure that, because many countries have these laws that they can actually say anything that's manufactured in the US we only use for the US, for example. So therefore, to kind of ensure against too strong national interest, we are trying to think through how to have the manufacturing sites many places.
This is in fact a question I wanted to pose you, because there was this scientist from Mount Sinai whose name is Garcia Sastre, who advised me to take this very seriously. I mean, he was imagining, he's mapping the proteins of the virus himself in New York, and he said to me, one thing we have to be very worried about is that once one vaccine will be ready in one country, and it will be deployed in that country, and then after that it will go to other countries which are less fortunate. We have to take that into consideration, and you are doing that. You're already considering a way to minimize this risk.
Yes, so we're doing it in several ways. I mean, we're doing it legally, if you will, in the sense that in the contracts we have with the developers, they are signing up to our equitable access policy, which requires them to make it available to those in need, independent of their ability to pay. And we have what we call step-in rights. So if they don't live up to that, we can actually go in and kind of take the technology and put it somewhere else. Secondly, very practically, as I was talking about, we are sort of thinking through the logistics of having development in many cases.
Yes.
And thirdly, and maybe almost most importantly, is that we're urging the world to set up a globally organized, fair allocation system. And we think that has to be driven by the World Health Organization and other major bodies, and countries sign up to it in a way. But because we are using lots of public money here, and it, at least during the pandemic, we think it should be treated through such a global mechanism. If the virus continues for many years and becomes like influenza, then of course you can sort of have more traditional commercial system to take care of it.
Okay. But stay 1 second more on point two. I mean, manufacturally. I mean, how do you assure that there won't be a privileged access to only one nation, the nation which in practice you are saying that the same vaccine will be built with the same specifics, will be built in different countries?
Yeah, I mean, it's still very early. That's what we're exploring. So we have the possibility to do what's called technology transfers.
Oh, yeah, yeah.
And as you say, then have manufacturers in different places produce the same vaccine.
I see.
And if you think about it, it's also about manufacturing safety, because if this pandemic continues, and we could have scenarios where one manufacturing plant has to close because people are too sick.
Yeah.
Or you need sort of
it makes perfect sense, of course. I do understand. You also work with big pharma, so to speak. Aren't you afraid that their logic, I mean, their patent issues and commercial logic will slow down research?
No, not really. I mean, I think, well, first of all, we have entered into an agreement with one of the big pharma, so GSK.
Yeah.
And they are offering, their what's called
adjuvant.
Yeah, adjuvant free of charge.
Yeah.
And I think big pharma is kind of in the same boat as all of us in this situation. We're really concerned about keeping their traditional business going as well. And as I said, we have some, in our agreements, we have these clauses where the partners sign up to our equitable access policy.
Okay. A couple of last things. This sounds very convincing and really interesting, but how comes that it was, because you work with public money and private money, I mean money from the states and from philanthropists like Bill Gates, but you are not a public body, right?
No.
And
I mean, legally.
Yeah, legal, because the question was how comes that was needed something like you, an intermediary, an organization like yours, in order to make these things work?
Sorry, what was the question? How come? Or?
Sorry, why it was needed an organization like yours in order to speed up the process. I mean, we might say the World Health Organization exists since many years. They could be the one that do the work you are doing, and why it's not the case.
Yeah, well, I think one of the key reasons for that was exactly that. From the Ebola lesson, it was one of the lessons was that one really has to make sure that there's a good relationship between the public sector and the private sector.
Yeah.
So these, it's popular to talk about private-public partnerships, and WHO has a very strong mandate on being what they call normative. They give the rules, etc. So they have a little bit more talent to work as closely with the private sector than we do. And this was part of the government's wish that this was indeed even a public-private philanthropic partnership. Yeah, that was the background.
So in a way, you were more flexible, you were more capable and less bureaucratic than World Health Organization in order to make this, to make all of these moving parts work together.
You can write that. I will not be. I don't want to be cited saying that we are more flexible than World Health Organization. Because I mean, we work very well with the World Health Organization, and we are totally dependent on that extremely well collaboration. But I think if you ask our investors, that's part of the reason for setting it up this way. Yes.
Okay. Last question. What is your background, and together with that one, how do you choose your scientific committee?
You mean my personal background?
Yes.
Okay.
So it's two little questions.
Yeah. I'm a physician. I worked I worked in sort of public health space most of my career. So I have a degree in public health and also in business administration, actually. So I'm sort of I'm a public physician. The scientific advisory committee is, ultimately appointed by our board. It's chosen for its diversity, for its knowledge, vaccine of virology, of course, and also of some from more general public health. So we're trying to have quite a breadth of capabilities and background. Yeah. And also a globally, try to achieve some global diversity.
Okay. Aren't you in the position to give us some more hope and optimism vis-a-vis of the time frame of 12-18 months? It's not conceivable that it's sooner than that.
What I can say is that we are pushing as hard as absolutely possible, and but as I said, I mean that is a very aggressive timeline. So no, I don't want to pose any false expectations.